NeuroLedger is a zero-knowledge gated lending protocol where Chainlink CRE computes risk policy off-chain and smart contracts enforce borrowing and liquidation on-chain. The problem we are solving is that most DeFi lending systems are open, static, and reactive. They don't support private eligibility, they don't separate policy from execution, and liquidation logic is often delegated to simple keeper boards. NeuroLedger introduces a different architecture. Borrower eligibility is proven privately through a zero knowledge proof. Borrower decisions are not executed immediately, they are routed through a Chainlink CRE workflow, and the protocol only executes borrowing after an on chain decision has been written and verified. Here's the system overview. On the left is the borrower and the dApp. The user generates or uploads a zero knowledge proof containing the public signals and it is submitted to Borrowgate. Borrowgate verifies the proof and emits a borrow requested event. That event triggers the CRE borrow risk workflow. CRE reads protocol state from lending pool, gathers external market context, applies deterministic approval rules, and Gemini AI Agent comes in to calculate risk score. The final decision is written on chain through the CRE borrower decision receiver and the approval registry. Only after that does the borrower call execute borrow. Borrowgate checks the registry and if approved, lending pool executes borrow for and transfers another token to the user. Now I'll show you the borrow flow live. So starting the borrow flow, I already have some Ethereum as collateral. You can see that I already have some token debt and here is the total annual balance in my wallet. So I'll upload a proof that I have already generated. Ideally, we would generate this proof from client. So you can see in this proof, we have the borrow amount, nullifier root. I'll go ahead and submit the borrow request. Borrow request does pop up the MetaMask. And let me confirm this. This is the architectural decision. First is the three-step process. First, we request borrow, then it goes first to Chainlink CRE that we will see now. I confirm this. Request. Once confirmed, next step would be running the CRE workflow. Let me go to the transaction here. It's still going. Okay, looks like it's confirmed. We'll go here and run the CRE workflow. Now the CRE workflow first computes all the deterministic checks that it needs to from lending pool, and then it goes to Fair Creed API and then to AI agent to calculate the risk score. Once compiled and executed, it does write the decision on chain. The risk score in LTV BPS is this. Risk score is 5998, which is less than 8,000. That's our threshold. Okay, you can see it's approved now. Now I'll go ahead and execute borrow. Now, since it's already approved, it will go to the lending pool and lending pool will transfer 10 NL tokens to my wallet. Let me confirm this. All recent activity can be seen here. Okay, looks like it's done. We refresh it. Okay, so yeah, my token depth increased. It was initially 157, now it's 167. That you can see from here. Next, we will go to the liquidation flow and see how liquidation would work. So I already have a liquidable position here. You can see the health factor is dropped below 1. And let's see what happens. This is going to be a partial liquidation since the health factor is not too low. So I'm now executing the liquidation orchestrator workflow. This workflow runs a periodic solvency sweep. It checks borrower's positions, reads health factor using Oracle-backed collateral valuation, identifies positions where HF drops below 1. Here, let it run. Here, one borrower has become under-collateralized. The liquidation workflow computes the minimum repay amount required to restore health factor above 1. It then forwards that value to protocol liquidation path and it is liquidated accordingly. So let's refresh this. Yes, you can see the token depth did decrease from 10 and the health factor has been restored successfully. So in short, to summarize, NeuroLedger combines private browser eligibility, CRE-based risk orchestration, AI-assisted credit scoring, and deterministic on-chain enforcement into a single lending protocol. Zatki controls access, CRE computes policy, smart contracts enforce execution.